Today we're going to look at a certain group of chemicals in organic chemistry called the alkanes. Alkanes we have mentioned before when we were looking at structure. Alkanes always have the structure CnH2n plus 2. So if you know how many carbons there are in the compound, you simply multiply that by 2 and then add 2 to get the number of hydrogens. Alkanes have only carbon and hydrogen, and they're all single bonds. All single bonds. They're also sometimes known as hydrocarbons because they only contain hydrogen and carbon. Now, these alkanes can have branches, and we'll be looking at what these branches might be and how they would affect their structure as we go through these notes. Now, there's one thing that you have to memorize, and that is the prefix that goes with the number of carbons. The first 4 you are not going to have used before. You may have heard of them. You've, I'm sure, heard of methane and propane and butane, but you've never connected that to a number of carbons. If we have 1 carbon, then the name starts with meth. If we have two carbons, the name starts with eth. 3 carbons, it starts with prop. 4 carbons, it starts with but. And from that point on, they make sense. 5 is pent, 6 is hex, 7 hept, 8 oct, 9 non, 10 dec. So those make sense, but the first 4 you have to memorize. So go around whenever the mood strikes you and just simply say meth, eth, prop, but, meth, eth, prop, but, meth, eth, prop, but. You've got to get that order in your head so that you will connect them to 1, 2, 3, and 4. So when we have these carbons, they exist in long chains and they have hydrogens attached to them. And we're going to look at the structures a little more in depth here in just a moment. But this table just kind of puts a lot of it together. Alkanes can also be cyclic in nature, and when they are, they're called cyclo alkanes. We have an example of the first few cyclic alkanes here, or cycloalkanes. Most of the time, cyclopropane is written as just a triangle, cyclobutane as a square, cyclopentane as just a pentagram, and pentagon would be a better term for it, and cyclohexane as a hexagon. So if you show the attached hydrogens, then it will look like those that are printed here, but otherwise they're just going to be these shapes that you see. Every point on the shape is a carbon, and that's why it has those names. We're still dealing with meth, eth, prop, but, etc. for the names of these compounds as well. So the first thing that we want to do is just to jump right in and write both what's called the expanded and condensed structures for both octane and cyclooctane. So for a condensed structure, let's go ahead and do the expanded structure first. As soon as we know it's octane, we know that it has 8 carbons. And carbon will always have 4 pairs of electrons around it. So when we're writing our structures like this, you can think of there being 4 dashes around. All of these are single bonds, so we're just going to fill up all the carbons. Now this first carbon has 4 around it. This chain of carbons in the middle are going to have 2 more lines drawn around them, and then the one on the end is going to need 3, representing again 3 pairs of electrons. So every carbon has 4 pairs of electrons, and each of those lines in octane are going to be attached to a hydrogen. And this is the expanded structure. It takes a little longer to write. Keep in mind that these lines can always be substituted with 2 dots, pairs of electrons. I never write it that way, but if you saw it that way, don't let it freak you out on the AP test. So there's the expanded structure. Writing it as a condensed structure is a lot quicker. We're simply going to write each carbon with its own hydrogens immediately after it. So this is going to be CH3 for the first carbon, and from that point on, you can put dashes in between, or you can simply write it next to each other. Again, the dashes in between are optional. So there's 4, 5, 6, 7, and then our 8th carbon on the end is going to be CH3 because it has 3 carbons. So there's our condensed structure. You will also see it written as C8, H, remember it's 2N plus 2, so H18, but for an organic chemist, that actually does us no good because it doesn't tell us anything about the structure of this compound. I'm going to draw in these dashes in red. Again, the dashes are optional. Some people like them, some people want to leave them out. But there's octane. Now, cyclooctane is going to be, now I'm not the best artist in the world, but we've got to have an octagon. Remember that each one of the points has a carbon on it, but I'm going to do the condensed structure first, so all I would need to do is just write that octagon. That's not the best octagon in the world, but we're going to keep it. Okay, so there's our condensed structure for cyclooctane. Now, if we want to write this as an expanded structure, then we need to do it like this. So we've got 8 around, and each of those carbons right now only have 2 pairs of electrons around it, so every one of them is going to need a hydrogen. Condensed structures are a whole lot easier to write, but unfortunately we can't see much about bonding and things like that when we're writing a condensed structure, so there are applications where we really need to know how to write these expanded structures. So it's not for nothing that you're learning to write all this out. So there's the expanded structure for cyclooctane. Now, another thing to remember is that this does not have to follow a straight line pathway. It's not a straight line anyway. All of these bonds, remember, in here are tetrahedral. So they're all in that tetrahedral shape that we've talked about in class. So this is definitely not a straight line. And I'll demonstrate that in class, but I wanted you just to think about the fact that if it's tetrahedral, then you're going to have bends everywhere in this structure when it's three-dimensional. But we can also show this a variety of different ways. For instance, I could say that the carbon was starting up here and that it was going this way and then down this way and here and over here and here. I've still got 8 carbons. They're all in a row. I'm not going to draw all these hydrogens on. We're just going to assume that all these hydrogens are there at the end of each of these, and that would still be octane. It doesn't matter how branched it is, we're always going to look for the longest carbon branch when we start naming these compounds and seeing what kind of compounds we have. So that's important to know. So branched alkanes, how are we going to write the formula or write the formulas and name these? First thing you've got to do is to find the longest carbon chain and number it. And you've got to start with the end that's closest to a branch. So if I start over here, I'm going to start in green. The green is not going to be my final numbering system, but it's going to start me out. There's 1, 2, 3, 4. I could go 5, 6 that direction. I could go 5, 6 this direction, but I could go 5, 6, 7 in this direction, which means that this is my longest chain. So that's how I want to label it, again, as my longest chain. So I want to start numbering it from the end closest to a branch. So let's look at the fact that if I'm numbering this 1 through 7, here is a branch that's off the line, and here is a branch that's off the line. So if I were actually going to name this compound, then I would have to start with the 1 down here, because in going from the left, this branch right here is on the 4 carbon, and this branch is on the 6 carbon. If I number it from the other direction, 1, 2, 3, 4, 5, 6, 7, then this branch is on the 3 carbon, and this branch is on the 4 carbon. So I'm numbering it in a shorter direction if I number it from right to left. So if I were going to name this compound, then the first thing I would do is realize that this is a 1 carbon branch, so that's a methyl branch. Branches end in YL. They're called alkyl groups. So YL, that's a methyl group. This has 2 carbons, so meth-eth-prop-bute. This is an ethyl group. So I would need to show that while I was naming this. So what I would do is to write down, and I always do it in alphabetical order. So eth comes before meth. So I'm going to start out telling it where the ethyl group is. So I'm going to start out 4 ethyl. Now I have to tell it where the methyl group is. So based on my red naming or red numbering system up there, it's 3 methyl. And now I named the longest branch. Since there are 7 carbons in the longest branch, this is heptane. And that last part is all one word. So 4-ethyl, 3-methyl heptane is the name of this compound. So I would suggest that for the first 2, see if you can stop this for a moment and see if you can figure out where the longest branch is, determine which direction you would have to number it, and label your groups that are branches off of it. Try that real quick, and then we'll start back up. So hopefully you did this. And if you did, you would notice that although this has 1, 2, 3, 4, 5 is the longest chain, I'm going to want to start from this direction because it's closest to a branch. So 1, 2, 3, 4, and 5. So when I name this, this is going to be a pentane. But first I need to tell it where the branches are. Notice that both of the branches are a methyl group. Since both of the branches are a methyl group, I am going to have to tell it twice where these are. So I'm going to call this 2, 2, and then I have to tell it again that there are 2 methyls. So this is going to be 2, 2, because they're both on the 2 carbon. Dimethyl. Those are the only 2 branches, so now I can just tack on pentane. 2,2-dimethyl pentane. In this next one, when I name this, I want to make sure that I have counted out the longest chain. And there's 1, 2, 3, 4, 5, 6 is the longest chain here. So I have to keep that in mind. And it looks like if I start numbering from this direction, if this is my line right here, then this is a branch, this is a branch, this is a branch, and this is a branch. So it looks like I need to start counting from this direction so that my first branch is on the 2 carbon. If I started it from the other direction, my first branch would be on the 3 carbon. I will have to start in the direction with the closest branch. So there's my branch, excuse me, my line with the branches. So it looks like this is going to be a hexane. So since this is a hexane, I could write that at the end just so I don't forget it, but I usually don't do that. I rarely forget that part of it. But now we start having to name the branches. They're all methyls. I'm just going to put an M beside each one to indicate that they're all methyl groups. So it looks like we've got 2, 3, 3, right? 3, 3. And the last methyl group is on the 4. Do you remember what our old term for 4 was? It's tetramethyl. There are 4 methyl groups, and now I'm going to tack on the name of it, which is hexane. So 2,3,3,4 tetramethylhexane is the name of this compound. My notes were actually wrong. I missed that the branch was longer, and I've got it down as a pentane. So be careful on counting out your longest chain. Okay, in the next one, we need to count out the longest chain. And it looks like we can have the longest chain from here. There's our longest chain. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Now let's see where our closest branch is. We've got an ethyl here. Looks like we've got a methyl here and a 3 carbon one here. So this is going to be a propyl, right? So there's a propyl, there's a methyl, and there's an ethyl. Okay, now here's another weird thing that might come up. Notice that we've got both of the branches start on a 4. It doesn't matter which direction you go. If you number from the right, then the propyl starts on a 4. If you number from the left, then the ethyl and the methyl end up on the 4th carbon. So which one do you start with? Alphabetical. Which one of those is alphabetically first? Ethyl. So we're going to say that ethyl should be on the first or closest branch, which means we need to start numbering from this direction and make that the 4 carbon. So this becomes 4 ethyl. And since methyl is next, it's still on the 4 carbon, so we do 4 methyl. 5 for the propyl. I should have put an L on there. 5 propyl. A little long on my L. So 4 ethyl, 4 methyl, 5 propyl, and the last part of it, since there are 8 carbons, is going to be octane. So hopefully that's what you got. Maybe not, because that one was a little bit tough. So the last one here is a hexagon. So how are we going to name that? It's going to be a cyclohexane. And we always start numbering on a branch. Doesn't matter, since I normally do left to right, I'll just call this the 1 carbon and this the 2. It doesn't really matter because either way you number it, you'll still come up with the same thing. The fact is that this is 1, 2. I need to put it on the same line with my cyclohexane. 1, 2 dimethyl cyclohexane. So that's naming these compounds. So before you panic, they're not going to ask you to name these on the AP test. I'm asking you to do it because we're taking a step further so that the things they do ask you on the AP test will seem easy compared to what I've asked you to do on this worksheet that you'll do for this. Okay, now as far as writing the formulas, I actually think writing the formulas is easier. You just do exactly what it tells you to do. I always pick out what it is first, which is heptane, and I'm going to make hept carbons. So I'm going to make 7 carbons. So there's my 7 carbons. It says that the 3 carbons should be methyl. And when I write these and I'm drawing the structure, I always make the left-hand one be my 1 carbon. So 3 methyl is going to go right here. 4 diethyl. So the next carbon is 4. So that's going to be my CH2CH3 for the ethyl group. 2 carbons, CH2CH3 for another ethyl group. So there are my branches, and now all I have to do is to fill in the hydrogens for my carbons. This first carbon already has 1 pair of electrons, so it needs 3 hydrogens to fill it up with 4 pairs of electrons. This next carbon has 2, so it needs 2 hydrogens to fill it up. This one already has 3, so it only needs 1 more. The next one, this carbon, already has 4, so we're done on that one. This one needs 2 because it has 2 pairs of electrons attached to it already. So does this one. And finally, that last carbon, since it's only attached to has 1 pair of electrons attached to it, needs 3. So there is the condensed structure. Again, you can have those dashes between, but you don't have to. Now, as far as the expanded, all we're going to do, it's going to take me a little bit more room here. I'm afraid I don't have quite enough room. We'll see. I'm going to do the same thing, but this time I'm going to put lines for all the carbons, or excuse me, for all the hydrogens. So the first thing I do, let me just draw out all my 1, 2, 3, 4, 5, 6, 7, 8. I know this is an alkane, so they're all going to have there are 4 pairs of electrons around it. This first hydrogen, or first carbon, has all hydrogens. So does the second one. This carbon has a hydrogen, but it also has a carbon attached to it with its hydrogens. Now this one's going to be a challenge. In fact, I think I'm going to erase part of this one so I can try to get it in. I may draw an extra big line between it so I can get it all in, because this one's got to be an ethyl group. I'm going to erase even more, because this one's going to need some hydrogens around it too. Expanded structures are a little bit more challenging. Okay, this one has to be an ethyl group too, so it's going to look like this. Again, you're not going to face anything this hard on the AP test, but if you can do this, you'll think the AP test is easy. Okay, so there's the structure for this particular compound. I think you can see why we almost always do the condensed form whenever we're writing the formulas for these. So let's get rid of this. And now we're ready to do 1-methyl-4-propyl cyclopentane. So cyclopentane, let's do it off to the side so I'll have room for those branches. Cyclopentane is going to look like this. And actually this one is named wrong. This should be 1-methyl-2-propyl, not 4, 1-methyl-2-propyl cyclopentane. So CH3 for the methyl group, and propyl, remember, is 3 carbons. So it's going to look like this. So there's that structure. And if we wanted to draw the expanded form, then we would write it as a carbon. I always think of a pentagon as being like a house with a roof. It's about the only way I can draw it. Then we've got the C up here, that had the carbon up here that has its hydrogens. We've got that propyl group. The only thing I like about the expanded structure is it's easy to see where those hydrogens go, because it's really easy to see the 4 bonds. Now all these other carbons that are on here are going to need an extra hydrogen if they already have a branch, and 2 extra hydrogens if they don't have branches, in order to get their 4 pairs of electrons. If you see a carbon without 4 lines around it, then something is wrong. So that's just an introduction in how to write the condensed and structural formulas for these. So give that worksheet a shot and see how you do on it, because like I said, if you can do this, you can do anything that AP tester is going to throw at you as far as structure is concerned.